What we're going to be doing next is doing a couple of examples of solving systems of equations by substitution. The first system we're going to be solving is x minus y equals 6 and 2x minus 3y equals 20. Step 1 in solving a system of equations is to get one of my equations into either x equals or y equals format. I'm going to be working with equation number 1 because it looks like I could get x equals just by adding y to both sides. So I'm kind of going to scoot that over. X minus y equals 6, and I'll add y to both sides, and that gives me x equals y plus 6. The next thing I need to do is to substitute that expression into my other equation. So I'm going to take y plus 6 and replace the x in my second equation. So that's going to give me 2, and instead of times x, it's going to be times y plus 6. So 2 times y plus 6 minus 3y equals 20. Now I don't have a numerical value for y yet, but when I work through this equation, I will be able to tell you what y equals. So I'm going to go ahead and solve algebraically. So I'll distribute that 2. So 2y plus 12 minus 3y equals 20. I'm going to combine like terms. So I get 2y minus 3y is negative y plus 12 equals 20. Subtract that 12 from both sides. That gives me negative y equals 8. And then divide by negative 1. So I get y equals negative 8. Now that's the y value that's going to be in my ordered pair. And to get the x value, I'll take the negative 8 that I found for y and substitute it into my expression, my equation that I found on the first step. So I'll have x equals negative 8 plus 6, or x equals negative 2. So my ordered pair solution is negative 2, negative 8. Now let's see how this plays out graphically. I have two lines, so I'm going to graph x minus y equals 6 first, and I'm going to graph this by putting it into slope-intercept form. So I will subtract the x, so I get negative y equals negative x plus 6, and then divide by negative 1, so I get y equals x minus 6. So I know I have a slope of 1 and a y-intercept of negative 6. So I'll go to negative 6 for my y-intercept, and then use my slope of 1 to graph that line. And connect those dots. My other equation, 2x minus 3y equals 20. I'm going to graph that one using the cover-up or blot-out method. So to get my x-intercept, I'm going to cover up the y. So I cover up the y, and that gives me the equation 2x equals 20. So 2x equals 20 tells me that x equals 10, which gives me the x-intercept 10, 0. So I'll graph that there. And then when I cover up the x, that gives me the equation negative 3y equals 20. Divide by negative 3. That gives me y equals negative 20 over 3. So I have the y-intercept 0, negative 20 over 3. Now, in order to graph that, I'm going to approximate, because I know that 21 divided by 3 would be 7, so negative 21 over 3 would be negative 7, but I have 20 over 3, so I got to go off 1/3. And then to graph my line, I'm just going to connect those two dots. And when I look at where those two lines cross compared to my solution of -2, -8, I can see that at -2, -8, right here, my two lines cross. And that is the solution to that system. Let's look at a second example. 3x minus y equals 5. And x plus 3y equals 5. Now to solve this by substitution, I want to pick the equation that's easiest to work with. So again, probably equation 2. I can tell that if I just subtract my 3y over, I'll be able to have a value or an equation for x. X equals -3y plus 5, which I can replace this x for right here, -3y plus 5. So I'll have 3 times -3y plus 5 minus y equals 5. Now again, I'm going to distribute that 3, so -9y plus 15 minus y equals 5. I'm going to use some algebra to solve this equation for y. Combine those like terms, gives me -10y plus 15 equals 5. And I will subtract the 15 from both sides, so I get -10y equals -10. Divide by -10. That gives me y equals 1. That's going to be the y value of my solution will be 1. And then I'll take y equals 1 and plug that in to the equation I got in the first step. So I get x equals -3 times 1 plus 5. So x equals -3 plus 5, which means x is 2. And that's what I'm going to use for the x value for my solution. Now I do want to check this by graphing. So we will graph 3x minus y equals 5. And I think I'll graph that one using slope-intercept form. So I'll subtract 3x. That gives me -y equals -3x plus 5. Then I have to divide by -1. So I get y equals positive 3x minus 5. So graph that. Y-intercept at -5. Slope up 3 over 1, up 3 over 1, up 3 over 1. Connect those dots. And then for my other line, x plus 3y equals 5, I think I'll use the cover up or the blot out technique. So if I blot out or cover up the y, that gives me x equals 5. So my x-intercept will be at 5, 0. And if I cover up or blot out the x, that gives me 3y equals 5. Dividing by 3 gives me y equals 5/3. So 0, 5/3 is my y-intercept. So if I go to 5, 0 on the x-axis, and 0, 5/3, so I have Each one unit is 3/3, so 3/3, 4/3, 5/3 right there. When I connect those dots, I should be crossing my other line right at that solution point of 2, 1. And that is exactly what happened. Here's my solution point of 2, 1. So as you can see, both the algebra and the graph come together. If there's any discrepancy between what you see on your graph and what you find algebraically, that's a really good hint to go back and figure out where you might have had a mistake. So rather than strictly relying on the graph to solve these equations, systems of equations, I highly suggest you go back and do the algebra just to make sure, because the lines don't always end up on integer coordinates. If this solution had actually been, say, 2.73, 1.02, I would have never been able to get that exact value by graphing. I would have had to do the algebra. So the graph is a really good way to verify what you found algebraically, because we can see visually what's going on, but it's not really a great way to rely on for your entire solution. So good luck graphing these systems, and we'll see you next time.